Hello everyone, welcome to my next video about friction. In this problem, we are going to apply D'Alembert's principle to solve the problem. Now let us look at the data. Like there are two masses A and B of 80 and 20 kg, but these two are tied together with the help of a thread or a wire. Now a force of 400 Newton is applied towards the left, which means the mass A and B will move in unison. So this is what is called as a connected bodies. This is what is called as connected bodies. Mass A and B will move in unison. Now between the block and the surface, there is a coefficient of friction of 0.27. Now the question is, we need to find the acceleration of the two bodies and tension in this thread. Since the block A and B are connected together, the displacement of A and B, velocity of A and B, and acceleration of A and B are same. You can see the mass of block A is 80 kg. Convert that into weight by multiplying with 9.81. Mass of block B is 20 kg. Convert that into weight of B by multiplying that with 9.81. In that way, weight of A is 784.8 Newton and that for B is 196.2. Then the coefficient of friction between A and B are same. Therefore, mu A is equal to mu B, which is equal to mu, which is taken as 0.27, which is the part of the question. Then already said, since block A and B are connected together, acceleration of A and B are same. Therefore, it is taken as simply A. Now to solve this problem, we need to first draw the free body diagram of B, then free body diagram of A, the free body diagram of block B. The weight of the block B is acting down, which is 196, which is balanced by normal reaction NB. The block B is connected to block A with the help of a wire. Therefore, if you draw the free body diagram of B alone, you have a tension of the wire. This tension in the wire will be acting towards the left. Since the tension pulls the block, this is the direction of motion and we know the force of friction will oppose that one. Therefore, FB is acting to the right. Tension on the left and FB is acting towards the right. Now let us first apply the condition sigma Fi equal to 0. There are two forces 196.2 and NB. NB is up, therefore positive. 196.2 is down, which is negative. So in that way, we have NB as 196.2 Newton. Next is we need to apply D'Alembert's principle. D'Alembert's principle says that summation of the force along the direction of motion minus MA is equals 0. Now if you look at the free body diagram, there are two forces T and FB which causes the motion or which is along the direction of motion, out of which T is same as, or the direction of T is same as the motion. Therefore, T is taken as positive, whereas FB opposes the motion. Therefore, FB is taken as negative. So T is positive here and FB is taken as negative here. So this T minus FB is the summation of the force along the direction of motion minus MBAB, because we are going to consider the second mass. Therefore, MBAB. So mass of B is 20 kg and AB is A. Already it is said. Then what is FB? FB is, force of friction is equal to mu N. Mu is 0.2. So in that way, FB is mu times NB. So T minus 20A equals 0.27 into 196.2. Upon simplification, we have the first equation. T minus 20A equals 52.97 Newton. So at the end of the, after drawing the free body diagram and applying the necessary condition, and we have the first equation, T minus 20A equal to 52.97 Newton. Now let us go to the second block, that is block A. Now this is the free body diagram of block A. The weight of block A is 784.9 Newton, which is acting down, opposed by normal reaction. Now there is a force of 400 Newton, which is used to pull the block A and B together. So this force is acting to the left. Now when you apply a force of 400 Newton, so the direction of motion is, you can see here, the direction of motion is to the left. To oppose this, we have a force of friction. You know, force of friction is always opposing the motion. Now this is the free body diagram. Together with the block A and block B are connected together with the help of a wire, with the help of a string or a wire. In the first part, if we take this as block B, the direction of tension in this wire is in this direction for block B, and for block A, the direction of tension is in this direction. For the block B, tension will be acting to the left, and for block A, tension will be acting to the right. You can see here. So here the tension is acting to the left, then here tension is acting to the right. Now after drawing the free body diagram, first apply the condition sigma Fi equal to 0. Now there are two forces, 784.8 acting downwards, which is opposed by Na, which is acting up. So upon simplification, Na equal to 784.8 Newton. Next we need to apply the D'Alembert's principle, so which says that summation of the force along the direction of motion minus Ma equal to 0. In this case, there are three forces, 400 Newton, T and Fa. These are the three forces, out of which 400 Newton is along the direction of motion, therefore which is taken as positive. The tension T is opposing the motion, so it is negative. The force of friction Fa also opposes the motion, therefore it is taken as negative. So 400 minus T minus Fa. So this is the summation of the force along the direction of motion. Then we have mass of A as 80 kg. Then acceleration of A is taken as A, already it is discussed. Then what is Fa? Fa is 0.27 times Na. Fa is 0.27 times Na. Now bring T and A on one side, then rest on other side. Then upon simplification, we have T plus 80A equal to 188.107. This is equation number 2. So after drawing the free body diagram of block B and applying the condition sigma Fi equal to 0 and D'Alembert's principle, so we have the second equation, T plus 80A equal to 188.107. So at the end of, after drawing the free body diagram, from the block B, this is the first equation. From the block A, this is the second equation. Now we need to solve the equation 1 and 2. Upon solving equation 1 and 2, what we get is tension in the wire is 80 Newton. Then acceleration of A and B, that is acceleration of A, which is same as acceleration of B, which is simply taken as A, which is 1.35 meter by second square. So using D'Alembert's principle, tension in the block is 80 Newton and acceleration of the blocks A and B is 1.35 meter per second square. Thank you for watching the video.